The boundaries of our solar system are more mysterious than we could ever have imagined. The Voyager probes have discovered a gigantic wall of fire out there, and mysterious objects lurk in the darkness, from temperatures above 50,000 degrees to galactic collisions. Today, I'm taking you to the edge of our cosmic home, and believe me, what researchers have discovered there is absolutely fascinating. So be sure to stay tuned until the end. Welcome, everyone. In 1977, Voyager 1 embarked on what is arguably the most epic journey of human exploration of the universe. Write to me if any of you were already around at that time, or perhaps even actively witnessed the launch of Voyager. I would be very interested to hear from you. Now, Voyager 1 has once again discovered something that shows us that the universe is full of surprises, and that's a whopping 49 years after the mission began.
If these fascinating discoveries excite you as much as they do me, then go ahead and subscribe to the channel right now. Subscribing costs nothing, you won't miss any more videos, and it helps me out a lot. If you've already subscribed, giving the video a thumbs up really helps. 5,000 likes is the magic threshold for the YouTube algorithm. Thank you so much, everyone.
Let's start with one of the most spectacular discoveries ever. The legendary Voyager 1 has found something at the outer edge of our solar system that sounds like something out of a sci-fi movie. A gigantic wall of fire with temperatures of up to 50,000 degrees, hotter than the surface of the sun, but how can it be so hot so far out in the solar system? To understand what is going on here, we first need to clarify where exactly this mysterious region is located and why it is so important for our understanding of space. And for that, another question is essential: where does the solar system actually end? The question is more complicated than you might think. You could say it ends where the last planet orbits, or perhaps only at the Oort Cloud, where the sun's gravity is just strong enough to keep small objects such as comets in its orbit. But NASA usually uses a different definition, namely that the boundary is where the sun's magnetic field meets the interstellar medium, the so-called heliopause. The sun constantly sends a stream of charged particles into space, known as solar wind. This wind races through our solar system at enormous speed, past the planets, until it finally encounters resistance about 3 times as far out as Pluto. There it meets the interstellar medium, the thin gas between the stars in our galactic neighborhood. Or, as NASA describes it, this forms a gigantic bubble around the sun and its planets, known as the heliosphere. At the boundary of this bubble, 2 powerful forces collide: the outward flowing solar wind and the interstellar wind from outside. The result is spectacular, and this is precisely where Voyager 1 made its groundbreaking discovery. But first things first, Voyager 1 is a true marvel of technology. Launched in 1977, just a few days after its twin probe Voyager 2, it was originally intended to explore only the outer planets. But this incredible machine exceeded all expectations. Today, almost 50 years later, Voyager 1 is the human-made object farthest from Earth, an incredible 24 billion kilometers. Back then, unlike today, there was truly quality workmanship. Especially impressive. On board, Voyager 1 carries a golden record with greetings from humanity for any potential extraterrestrial discoverers who might one day come across the probe. It contains animal sounds, baby cries, sounds of nature, and music, in a way, a kind of cosmic message in a bottle from humanity. On August 25, 2012, Voyager 1 made history. It was the first man-made object ever to break through the heliopause and enter interstellar space. Voyager 2 followed in 2018. But what the probes discovered there surprised even the most experienced scientists. This is where it gets really spectacular. Voyager 1 measured temperatures between 30,000 and 50,000 degrees at the heliopause. By comparison, the surface of the sun is only 5,500 degrees hot. This region is therefore also referred to as a wall of fire, although it is not real fire, of course. The fascinating thing is that even though the temperatures out there are so extreme, Voyager 1 was able to pass through this region completely unscathed. How is that possible? The trick lies in the extremely low density of this region. NASA heliophysicists explain it this way: it's a narrow, scorching boundary, and the space probe sailed right through it. The extreme heat is caused by the collision between the superfast solar wind and the slower interstellar medium. This collision creates magnetic turbulence and compressions that cause particles to enter a higher energy state.
But how can something be so hot without a flame burning? By the way, that would also make a good pickup line at a club, now that I think about it. How can you be so hot, baby, without burning? Okay, seriously, don't take any dating advice from me. It can only go wrong.
In any case, the answer lies in the physics of plasma. What happens out there is basically a cosmic blast furnace. When the solar wind hits the interstellar medium at enormous speed, the particles are accelerated to extreme speeds by magnetic turbulence. And this kinetic energy corresponds to the high temperatures measured. But the region is so thin that there is hardly any matter present, which is why Voyager was able to fly through it unscathed. One of the biggest surprises, however, was not the heat, but the orientation of the magnetic fields. Scientists had expected the magnetic field beyond the heliopause to behave completely differently. Instead, after a long evaluation of the data from both Voyager probes, they discovered something truly astonishing. The magnetic field beyond the boundary runs almost parallel to the magnetic field within the heliosphere. NASA explains that an observation by Voyager 2's magnetic field instrument confirms a surprising result from Voyager 1. The magnetic field in the region beyond the heliopause is parallel to the magnetic field within the heliosphere. This discovery turns previous models of our cosmic protective bubble upside down and suggests that our solar system is more closely connected to the galactic environment than previously thought. NASA added to its statement, with Voyager 1, scientists had only one sample of these magnetic fields and could not say with certainty whether the apparent alignment was characteristic of the entire outer region or just a coincidence. The magnetometer observations from Voyager 2 confirm the findings of Voyager 1 and indicate that the two fields match. Incidentally, this wall of fire is not only a fascinating scientific phenomenon, it also plays a crucial role in our survival, because the heliosphere acts as a gigantic protective shield that keeps dangerous interstellar radiation away from us. Without this cosmic protection, life on Earth would be much more difficult, if not impossible. The new findings about the magnetic connections therefore have important implications for our understanding of radiation protection for Earth, and as a result for future manned space missions. Because if we want to travel to other star systems one day, we need to understand the dangers that lurk at the boundaries of our cosmic home. Unfortunately, the Voyager probes will not function forever. The aging plutonium batteries can only power a few instruments, but NASA is skillfully juggling the available energy to keep the valuable sensors running. But we have to face the bitter truth. In a few years, the last instruments will probably fall silent. But research continues. This year, the Interstellar Mapping and Acceleration Probe, or IMAP for short, is scheduled to launch to observe the heliopause from within, measuring the interaction between solar wind and interstellar medium with unprecedented precision. IMAP will also clarify how charged particles are accelerated, and that is a crucial factor in protecting future astronauts on interstellar missions. What Voyager 1 and 2 have discovered out there at the edge of our solar system is more than just a scientific curiosity. It is a glimpse into the future of humanity as a spacefaring species. This glowing frontier shows us that even after almost 50 years in space, our small solar system is still full of secrets. Voyager 1 and 2 continue to float through interstellar space, listening to the secrets of the stars and sending messages from the burning edge of our cosmic home back to Earth. Their final message, a signal from the blazing edge of the solar system, could be their most important yet.
We just talked about the firewall that the Voyager probes discovered. But there is an even more gigantic structure, compared to which the cosmic firewall seems tiny. For the first time, researchers have mapped a huge magnetic structure surrounding our entire solar system. It is the magnetic field of the local bubble, a vast region that surrounds us. This discovery changes our understanding of how our solar system is embedded in the cosmic environment. Now you'll find out what this magnetic supershell is all about.
Our solar system is located in the local bubble, a huge void about 1,000 light-years across that spreads out around our star, and this superbubble is probably the amazing result of one or more supernova explosions. Such bubbles are not uncommon in our home galaxy, the Milky Way. Imagine the galaxy as something like Swiss cheese. There are lots of holes everywhere, and these holes are relatively common. They are created when very large stars explode in what is known as a supernova. After the explosion, a beautiful supernova remnant remains, but what is much more important for our topic is what happens during the explosion. The shock waves from the explosion blew away everything that was around the star. Like a galactic snowplow, charged dust particles and gases were piled up at the expanding edge of the shock wave in the local bubble. That is why many dust remnants and gases still stick to the edge of our superbubble, forming star-forming regions where stars can form from the existing materials such as the torus molecular cloud. This is an extensive accumulation of gas and dust, and since the shock waves have blown everything away, a large void remains inside This is often referred to as the local volume, and is basically nothing more than a largely dust-free space in the immediate stellar environment of our Sun. And this space around the Sun is the local bubble. It formed a few million years ago, which is only just now in cosmic terms. We don't even know for sure whether one supernova or several were involved. In any case, the pulsar Geminga is considered one of the culprits for our local bubble. It is a neutron star in the constellation Gemini that was created in a supernova explosion and is one of the closest pulsars to us. And apparently this Geminga once swept right through the solar system and is responsible for the relatively low density of interstellar matter. A sweeping pulsar like that would be pretty handy at home too. Then my wife wouldn't always tell me to tidy up. Okay, so now we know that the local bubble was created by the explosion of one or more massive stars, and the space around our Sun is yawningly empty. Theo O'Neill from the Harvard-Smithsonian Center for Astrophysics says, "The universe is full of such superbubbles which promote the formation of new stars and planets and influence the structure of galaxies. By learning more about the physical processes that shape our local bubble, we also learn more about the evolution and dynamics of such superbubbles in general." Thanks to the work of researchers at the Harvard-Smithsonian Center for Astrophysics, quite a bit has been known about the structure and size of the bubble since early 2022. The bubble is about 1,000 light years across, and the Sun is located pretty much in the center of the local bubble in a region called the local flake. The entire bubble is permeated by complex magnetic fields, and astronomers at the Center for Astrophysics have now published a unique 3D map showing the bubble's magnetic field in unprecedented detail. I never cease to be amazed at how far research has come and what we humans are capable of achieving in a positive sense. We are familiar with the Earth's magnetic field, which protects our planet from dangerous solar radiation. And the magnetic field that has now been mapped is basically also a kind of protection because it shields our entire solar system from dangerous cosmic space radiation. In this respect, it is very good and very important to know as much as possible about this structure. Researcher Alyssa Goodman says, "We have known for a long time that magnetic fields play an important role in many astrophysical phenomena, but studying them is notoriously difficult, Yafu." And now, however, the researchers have achieved another milestone and have created this 3D map of the magnetic field of the local bubble. To do this, astrophysicists analyzed data on the polarization of radiation in the Milky Way from the Planck satellite, an ESA microwave telescope. The radiation oscillates in certain directions, and these directions provide information about where the dust is located at the edge of the local bubble and how it is magnetized. The famous Gaia satellite, which scans our entire sky optically in 3 dimensions, was also involved and recorded the polarization of starlight. The result of this data analysis was ultimately the first 3-dimensional magnetic map of our home bubble. But what exactly do we see in the representation of the bubble? It is clear that the surface, that is the area surrounding the superbubble, is strongly magnetized. Inside, however, we find hardly any magnetic activity, and the orientation and intensity of the magnetic field largely coincide with the already measured topography of the local bubble. With the findings of the new 3D map, researchers can now explore our superbubble in a whole new way. This new knowledge is important, for example, for learning more about the formation of stars and planets, because magnetic fields have a very large influence on the flow of gases and dust, and that is, after all, the basis for the formation of new stars. This means that magnetic fields can regulate the conveyor belts that transport gas and dust to the star factories. In other words, magnetic fields can influence where a new star ultimately forms. Or, in the words of researcher Goodman, with this map, we can finally explore in more detail how magnetic fields influence star formation in superbubbles. And not only that, magnetic fields probably have many more effects that we are not yet fully aware of. After all, space is like the Swiss cheese mentioned above, full of such superbubbles that influence the formation of stars and planets, and thus also have an impact on the overall appearance of the galaxy. For me, this map is absolutely groundbreaking work. Think back to the first maps of the Earth when sailors returned with their impressions of the New World and mapped everything. That was revolutionary at the time, and we now live in an age where it is no longer the Earth that can be mapped, but interstellar space.
At the end of our journey to the edge of the solar system, perhaps the most unsettling discovery awaits us. This entire region in the outer solar system that we've been talking about could one day be destroyed because a rogue star named Gliese 710 is heading straight for us. It will plow through the Oort Cloud, knocking billions of comets out of their orbits. Some of them could end up on a collision course with Earth, and this could last for several 100,000 years. How dangerous will this be? And is there anything we can do about it? Here's the answer.
Yes. A star is indeed hurtling towards our solar system, and not just any distant point of light, but one of our direct galactic neighbors. Its name is Gliese 710, and it's quite something. But before you panic and start digging bunkers, let me first explain how something like this is even possible. Basically, every star has a fixed place in its star system. Our solar system sits on one of the outer spiral arms of the galaxy and orbits the galactic center together with billions of other stars. A complete orbit takes about 225 million years, which is a galactic year. So we are not only racing around the sun with the Earth, but also through the galaxy with the entire system. Here you can see how to imagine this movement through the galaxy, but the positions of the stars are not completely fixed. In addition to this galactic motion, each star also has a certain amount of proper motion. Over very long periods of time, this can cause the distances between individual star systems to change. Normally, however, stars are very polite and respect the privacy of their neighbors. They keep their distance.
But then there are a few exceptions. Just like with people, there are also some stars that simply can't stick to the rules of keeping their distance. These stars are called rogue stars, or in German Schurkenstern. They move completely independently from the other stars and don't take part in the communal galactic dance. In a way, they're the troublemakers of stellar society. Gliese 710 is one such rogue, and unfortunately, it's on a direct collision course with our solar system. Yes, exactly how head-on this collision will be still needs to be determined, but in any case, it's going to pass extremely close to us. Scientists have used the highly precise data from the Gaia Space Telescope to calculate exactly when this uninvited visit will take place. In 1.35 million years, Gliese will pass through our solar system. I can already hear some of you saying, "Dude, why should I care about something that's going to happen in over a million years?" At first, that sounds like an unimaginably long time, but on a cosmic scale, that's practically the day after tomorrow.
For comparison, the Earth has existed for 4.6 billion years, so 1.35 million years is really just the blink of an eye. Originally, researchers thought that Gliese would fly past us at a distance of about 60,000 astronomical units. That would be relatively far away, but the new, more precise Gaia measurements have shown that it will come much closer to us, only 13,366 astronomical units. That is still far away by human standards, but cosmically speaking, it will literally race through our solar system. To illustrate this, one astronomical unit corresponds to the average distance between Earth and the Sun, which is about 150 million kilometers. Gliese will therefore fly past us at a distance of about 2 trillion kilometers. That may sound like a lot, but the so-called Oort Cloud, the outermost region of our solar system, extends up to 100,000 astronomical units away from the Sun. Gliese 710 will therefore definitely enter this region.
But what is it about these mysterious outer regions of the solar system? The Oort Cloud is a gigantic spherical collection of comets and other objects that surrounds our solar system.
No one has yet been able to observe the Oort Cloud directly. It is simply too far away and the objects are too small, but it must exist, because there has to be a boundary somewhere where the Sun's gravitational pull becomes weaker than that of other stars. It is precisely here in the Oort Cloud that Gliese 710 will cause quite a stir. As it rushes through the Oort Cloud, its gravity will knock countless comets and asteroids out of their comfortable orbits and hurl them toward the inner solar system. With an apparent brightness of -2.7 magnitudes, Gliese will be one of the brightest objects in the night sky. Brighter than Jupiter and all other planets except Venus. Sirius, currently the brightest star, has a magnitude of only -1.46. Gliese 710 will therefore be more than 3 times brighter and will even be visible during the day. It will also move extremely quickly across the sky, but will this alien star be dangerous for us? The flyby of Gliese itself is unlikely to directly threaten life on Earth. It will not come close enough to disrupt our planetary orbits or cause catastrophic tidal forces. The real danger lies in the impact on the Oort Cloud, as scientists estimate that Gliese will eject about 0.1% of all comets from the Oort Cloud. That may not sound like much, but we are talking about trillions of objects. About 0.01% of these comets could be sent on trajectories that take them into the inner solar system.
The researchers expect that after Gliese's visit, about 10 new visible comets will appear each year, and this will continue for millions of years. So for amateur astronomers, this is an absolute feast, but it also means that the likelihood of impacts on Earth will increase significantly. The first 600,000 years after the flyby could be especially critical. During this time, the comets that are hurled directly toward the Sun will arrive. and they will all come from the same direction, namely from the spot where Gliese was farthest from the Sun. Well, that doesn't sound very pleasant, but of course Gliese isn't the only star that could pass through the solar system at some point in the future.
And there's a new study on the general danger posed by such rogue stars. It shows that passing stars can not only disrupt the Oort Cloud, but can even eject entire planets from the solar system. Simulations show that within the next billion years, Earth has a 1 in 500 chance of either being ejected from the solar system or colliding with another planet. That may not sound like much, but it is significantly higher than previous estimates. Mercury is the worst off as the innermost planet. It is statistically the most unstable and could be lost with a 50 to 80% higher probability than Earth. But folks, don't panic. These extreme scenarios are still very unlikely. So as far as Gliese is concerned, we can remain relatively relaxed. The event will be spectacular to watch and will bring us many new comets, but humanity will most likely survive it. Perhaps our descendants will even develop some kind of comet shield or use the many new visitors as sources of raw materials for their space civilizations. However, if at some point another star races closer through the inner solar system and directly ejects the planets, then our options for action will probably be rather limited.
I hope you now have a good insight into the spectacular discoveries that have been made at the edge of the solar system. Of course, I'll keep you updated here on the channel about all further cosmic findings. So if you haven't already, go ahead and hit the subscribe button so we can reach 400,000 here on the channel, and don't forget to give a thumbs up for 5,000 likes.
And now we travel to another exciting place, Mars. Back in the 1970s, the Soviets succeeded in sending probes to Mars, which provided us with some truly exciting images that hardly anyone knows about. To learn all about this groundbreaking mission and see the original images, be sure to click on the video displayed at the top right. It's very exciting. Otherwise, I'd say see you in the next video. Take care, everyone.